Good evening, and we welcome you students for a live webinar, for a quiz, for important question answer sessions on sound. Ninth science. What is the chapter of sound? Chapter 12.
Chapter 12.
NCERT. Important questions will be discussed and a quiz will be asked to the students. Before we begin, some MCQ questions and other questions could be there for the discussion. Students, let us give a small revision, recap what we have learned in sound. First thing student, first question is what is sound, how it is produced, and you have answered the question. Sound is produced due to
Vibration of particles.
Sound is produced due to vibrations. Okay? Of objects, and objects are made up of particles. That means any object which will vibrate will produce a sound. If I have a table, I hit a table. In the school, they hit the bell with a hammer. What happens? The particles of the bell starts vibrating and sound is produced. Okay, very good. Then what happens, student? The sound travels in the form of what type of waves are these?
Longitudinal
waves. Longitudinal waves, student, lengthwise. What it means? They are traveling as a longitudinal waves through a medium. Now, what do you mean by longitudinal waves, students? What happens when I say longitudinal waves? The particles of the medium vibrate parallel to the direction of the propagation of the wave. Is it true?
Yes, sir.
All right. And the sound propagates through a material medium, or a medium in the form of compressions and rarefactions. What are compressions, students? What are compressions?
So compressions means when particles come close to each other.
The particles are vibrating. Particles are coming closer, 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 closer. This is a region of high density or low density?
High density.
High density. All right. You have high density, low density. High density means high pressure. Low density. And they are propagating in the space. Now, what will happen? There are successive compressions and rarefaction, and sound energy travels. Sound energy, sound wave disturbance travels, ठीक है, but particles of the medium ठीक है, particles of the medium do not travel. Then what happens to the particle, students? They are vibrating about their mean position, equilibrium position. They forward, come back, they move and come back, they move and come back to the original position. Then what is propagating?
Yes, sir.
Energy. Then you said sound needs a medium to travel. Light can travel in vacuum also. Light is an electromagnetic wave, which is of different sort. But sound needs a medium to travel. And an experiment was done to show that sound does not travel in vacuum. Is it right?
Yes, sir.
If I remove all the material, then the sound will not be there. And what happens? The sound change in density from maximum value to minimum value, and again maximum to minimum. This type of situation continues to make one complete oscillation. And distance between two consecutive compression or consecutive rarefactions. What is that known as? Distance between two consecutive compressions or rarefactions. What is that known as, students?
Wavelength.
That is lambda, the wavelength. Length of the one wave, student, one wave. Wavelength. Then we discussed, student, what we discussed? The time period. What is a time period, student? What do you mean by time period? Time
Sir,
taken
time taken by two
by
consecutive
for one
compression.
complete oscillation. For time
Yes.
taken for one complete oscillation. And we discussed the frequency. What is a frequency, student? The number of oscillations per second. Number of oscillations per second in 1 unit time. And therefore, mu is equal to 1 by t. Mu is equal to 1 by t. Then what we discussed, students? What was the further, student? What we discussed further, student, in sound, that if speed of sound is v is the speed of the sound, then what happens? You know, mu is equal to speed by the wavelength. What it means, student? Then the speed v will be equal to, what is the speed v? mu into lambda. Mu into lambda. ठीक है? Meter per second. Speed. The speed is equal to. So this formula we are using for many numericals and questions. Right? Speed is equal to frequency into wavelength per second, meter per second. Okay. What else we discussed, student? The speed of sound depends on nature of the material, nature of medium. It is more in solid than liquid than gases. Is that true?
Yes, sir.
And then we discussed the speed of sound depends on temperature. What will happen if we increase the temperature?
Speed of sound will increase.
The speed of sound increases. With temperature, the number of vibrations per second increases. Then we applied the laws of reflection of sound were similar to laws of reflection of light. So sound waves are reflected back by the material mediums and makes an angle equal to the angle of incidence is equal to angle of the reflection. And incident, normal and reflected sound waves, they lie in the same plane. And therefore we talked of echo. What is an echo, student? For hearing a distinct sound, the time interval between original and reflected must be at least 0.1 second. 0.1 second. And the persistence of sound in auditorium is a result of repeated reflection of sounds. What we talked of? Repeated reflections of sound. What is the repeated reflections of sound known as, student?
Reverberation.
Reverberation. And you have seen in big halls, theaters, huge buildings, what happens? What they do, a lot of carpeting is done, curtains are there, and sometimes there is a board. What is the use of that?
To prevent reverberation.
And so that the sound is transmitted in all the directions. What they are curved from the top, so multiple reflections can take place, and the sound travels in all parts of the hall. Then we discuss certain properties of sound. What properties were discussed, student? Which depends on what, student?
Frequency.
More the frequency, more the pitch. We discussed the loudness. Depends on which factor?
Amplitude.
More the amplitude. More the amplitude, more the loudness. Then we discussed quality. Quality is determined by these are all the wave properties we discussed. Quality of the sound. We also discussed the intensity of the sound, student. How do you define intensity? The amount of sound energy passing each second through a unit area. Then we discussed audible range. What is the audible range, students?
20 hertz to 20 kilohertz.
We talked about infrasonics. What are infrasonics?
Whose audible range is below 20 hertz.
But then we talked of ultrasonic. What are ultrasonics?
Whose audible range is above 20 kilohertz.
We have discussed in large the applications. Applications, student. What is the ultrasound, student? We discussed sonar. What is the sonar, student? So many applications of the ultrasonic waves, and how to find the depth of the sea, underwater objects, and locate the underwater hills, valleys, okay, submarines, sunken ship, etc. We are using sonar techniques. So I hope we are quite familiar with the topic of sound. Are we?
Yes, sir.
Okay. Let us try to answer some of the questions, student. Question 1 is on the screen. Question 1 is on the screen, student. Note is a sound. Note is a sound. When we were discussing sound, student, what is the definition of the note in sound, student? Before I answer the question, let me see what we mean by note in sound.
Sir, it means the mixture of various frequencies.
When we have mixture of many frequencies, okay, that we called as note. What other definitions were given when we were discussing sound? Mixture of many frequencies, different frequencies when we observe. If we have a single frequency, what do we call as?
Tone.
Okay, single frequency. Then we call as tone. So this was discussed, student. The question is, note is a sound, a mixture of several frequencies. Is that the right answer?
Yes, sir.
That is true. Mixture of two frequency, false. Single frequency is known as tone. Always unpleasant to listen. What do you call that? Unpleasant noise?
Noise.
Okay, all this wrong. Okay, the correct answer is A. Mixture of several frequencies. And you get, student, 1 full mark for that. Our purpose is to understand rather than simply answering the question, because the questions are going to be changed in exam and there's a variety of questions. Main purpose of the quiz is to understand, revise the topic, and see how much learning is there to learn, student. Question number 2 is on the screen. A key of mechanical piano struck gently. Piano. You have seen piano?
Yes, sir.
Key. There's a key. And then struck again, but much harder this time in the second case. One, yeah, gently struck, then it is struck harder. Sound will be louder, but the pitch will not be different. First choice. What will happen? Sound will be louder, but pitch will not be different. Second, sound will be louder, pitch will also be higher. Sound will be louder, but pitch will be lower. Both soundness and pitch will remain unaffected. So the question is on two things. One is the pitch. Other is the loudness. Pitch depends on what factor, student?
Frequency.
Pitch depends on the frequency and loudness depends on
Amplitude.
amplitude. Now in this case, what is happening? If a piano is struck gently, struck again harder. If you struck gently and then you struck harder, student, what happens? What changes? What things will change?
Sir, amplitude will change.
You got to know an exact answer you have to give. No guessing is required. You have to find whatever answer you give will be accepted. Tell me, yes, which answer you are giving. A, B, C, D.
Sir, option A.
Option A is the correct answer. In this case, what will happen? Sound will be louder, but pitch will not be different. Frequency will not change, but in this case, amplitude will change. So this amplitude will change. Amplitude will change. And then what will happen? The sound will become louder. There will be no change in pitch. Therefore, the correct answer is A. This is wrong, false, false, false. This is true. The answer is A. Sound will be louder. Okay? Because amplitude is increasing. Pitch will not be different because frequency is not changing. Okay. Another question is coming on the screen, students. In sonar, we use what we use in sonar? Ultrasonic waves, infrasonic radio waves, audible sound waves. What are the waves which are used in sonar?
Ultrasonic waves.
That is the correct answer. We already applied the applications of ultrasonic waves in sonar. Ultrasonic waves are used. A is the correct answer. And therefore, full mark for that. Infrasonic waves. Where do we find infrasonic waves?
Sir, various animals can hear infrasonic waves.
Before the earthquakes, we have got an idea. Infrasonic. Which animal is able to listen infrasonic?
Rhinoceroses.
Okay. Their behavior will change. What about the radio waves? You are listening to different radio waves, audible sound waves. You are listening. Next question is coming. Sound travels in air. If particles of medium travel from one place to another, there is no moisture in the atmosphere. Disturbance moves both particle as well as travel from one place to another. We discussed this question so many times. How the sound propagates. How sound propagates, students. In here, air is a medium. What is the correct answer?
Sir, option C, disturbance moves.
Particles of the medium is false. No moisture, false. Disturbance moves, yes, disturbance moves. Both particle as well as disturbance travel from one place to false. This is true. So answer is a C. The disturbance moves. The wave moves, the energy is traveling, but particles do not move. Particles only vibrate about a mean position. This is the correct answer. Next question is coming on the screen, student. When we change feeble sound to loud sound, we increase its feeble sound. What is the feeble sound, student?
The sound which is very slow.
Not slow, low.
Yes, sir, low.
Loud sound. Then what we are changing? What we increase, it's increasing. What is increasing? What is increasing, student?
Amplitude.
As the amplitude increases, the sound will become louder. Frequency false, amplitude true, velocity false, wavelength false. So the correct answer then is, students, B, amplitude. All right, we drawn certain waves for that also, since we have seen it. Another question is coming on the screen, students. In the curve, half the wavelength is there are four choices: A, B, B, D, D, E, A, E. All right, you have 1 to 2 minutes to answer the question. And I say, oh, water, heal me. I'd sip some hot water. I have given you the basic rule. I have said that perimeter of any figure, be it any shape. Okay. I will keep your style of studying yourself. With me, you're going to work and just go to this. Use a figure like this. And they ask you to find the perimeter. For me, the perimeter will be sum of all the sides. Okay. What is the answer, students? So perimeter is always the sum of all the sides, whatever may be the figure. Now just read the question, what you want to say.
Sir, BD.
What about AB? What AB? Is it what is half the wavelength mean lambda by 2? AB is not correct. BD, what is BD, student? BD will be equal to lambda by 2. That is the correct answer. What is DE? Again, this is not, that will be lambda by 4. If I put it, this will also be lambda by 4. What will be AE? That will be equal to lambda. So this is false, false, and false. Then this is the true answer. So what is the correct answer? Is B choice, which is BD is equal to lambda by 2. This is a complete one wavelength. You can see that.
Yes, sir.
AE is one full wavelength. Started here. And one complete cycle, one cycle is completed. If I draw this and this also, what will be that value? This will be lambda by 2 also. Got it?
Yes, sir.
Is that distance between two? They are two successive. One is a trough, other is a crust. Trough and crust. Okay. Another question is coming, students. Earthquake produces which kind of sound before the main shock wave begins? Earthquakes, shock waves are coming, but before that, something else is also coming. What is coming in earthquake before the shock waves? Ultrasound, infrasound, audible sound, none of the above. Is anything coming or not?
Sir, coming.
What is coming?
Infrasound.
Ultrasound is false. Infrasound is true. Audible sound is false. None of the above false. Then the correct answer is B. Infrasound. Infrasound. Okay. That is the correct answer. Another question is on the screen. Infrasound can be heard by, we discussed this many times, student, again and again. Infrasound can be heard by certain animals. We told you can hear the infrasounds. Dog?
No, sir.
False. Bat?
No, sir.
False. Rhinoceros?
Yes, sir.
Human beings?
No, sir.
False. The answer is C. Rhinoceros. Okay. Another question is coming on the screen. Before playing an orchestra in a musical concert, a sitarist tries to adjust the tension and pluck the string suitably. By doing so, he is adjusting. Is it true? Sitar, you have seen a sitar? Sitar. A musical instrument, sitar, what do they do? They adjust the tension and pluck the string suitably. What is he adjusting? What is he adjusting by this method? Sitaris is trying to adjust intensity of the sound, amplitude, frequency of the star string, the frequency of other musical, loudness of the sound. What is he adjusting, students?
Sir, option C.
Intensity of the sound is false, amplitude is false, frequency of the star string with frequency of other is true, loudness of the is false, therefore the answer of this is C. So he is trying to adjust, student, the frequency of sitar string. Is the correct answer. Is the question coming, students? The given graph shows displacement versus a time for a disturbance traveling with a velocity of 1500 meter per second. Calculate the wavelength. How will you calculate the wavelength, student? What formula we are using? Displacement versus time. What is the answer? How will you do it?
Sir, we can use the formula V is equal to 1 by T.
Huh? Now, no answer is coming. Okay. First of all, the graph shows displacement. This is displacement. This is a time. What is the time period, student? Here, what do you mean by time period? Time for one complete oscillation. How much is the time period? Where is one complete oscillation? If I take this to this point, is it one complete oscillation?
Yes, sir.
That will be lambda. One complete oscillation is then how much? 3 minus 1, 2. What is this? Microsecond. What will be that? Micro, what is micro equal to? Time period is available. Okay. Then what is the formula? Lambda will be equal to what? V into T. What is the velocity? And what is the time period? How much answer we are getting? (15 to the 3). ठीक है, 3000 into 10 minus 6, 3 into 10 minus 3 meter. That is the correct answer.
Yes, sir.
The wavelength is 3 into 10 minus 3 meter. Okay. Another question is coming, student. Which of the two graph A and B represent human voice likely to be a male voice? Give reason. Male voice. Male voice. Now this is something difficult for students. How will they know? Male voice and female voice. What is the difference?
Sir, male voice is more loud.
This is A. This is A. What is the difference between A and B? This is
Sir,
toward
in
this.
B frequencies is more.
The frequency is more.
Yes, sir.
A has a lower frequency. ठीक है? And B has a higher frequency.
Yes, sir.
More vibrations per second in B. This is from here to here. And this is from, okay. More vibrations are there. More vibration, lower frequency. Lower frequency means less pitch,
Yes, sir.
low pitch. Higher frequencies mean high pitch sound. And the male voice, it has lower pitch, lower frequency. Then which is the correct answer?
A.
Then A. Answer A graph. Some questions, are like out of tune here, but we have to try and see what answers can be given. We may not have discussed these. Another question is coming, students. A girl is sitting in the middle of a park of dimension 12 meter is to 12 meter. On left side of it, there is a building adjoining the park. On the right side, there is a road adjoining the park. A sound is produced on the road by a cracker. Is it possible for the girl to hear the echo of the sound? Explain the reason. What is the condition for echo to be heard?
Sir, it should be received within 0.1 second.
The sound should come back, should be reflected back. If the time gap is around 0.1 second, you are saying. Okay? So we have to find the time gap student between the original sound and the reflected sound. You have 2 minutes to try the question. What is happening? Girl is sitting in the middle of a park of dimension 12 by 12. 12 by 12. Okay. On the left side, there is a building. This left side is a building. Okay. Adjoining the park, on the right side of the park, there is a adjoining park. So if there is a road, student, here some cracker. Where is she sitting? Girl is here, sitting in the middle of the park. Middle means how much distance? 6 meters. How much will be this, student? 6 meters. This will also be 6 meters. 6 meters. ठीक है? First sound, what will be the first sound? If the speed of the sound is given, or how much speed we take in air?
344 meter per second.
Okay. 344 meter per second. 344 meter per second. So if that sound reaches the girl from air directly without reflection, before reflection, that will be 6 meter distance. Then what will be the time? T1. How much distance by time? What is the distance? 6 meter.
Yes, sir.
Divided by 344 meter per second. Now if it goes and then come back, then how much distance is it covering? 12 plus 6. 18.
Yes, sir.
18 meter by 344 meter per second. Find the difference between the two. T2 minus T1. Find what is the value coming? Meter, cancel, meter, second. How much? 18 by 344 minus 6 by 344. Second. What is the value coming?
Sir, 3 by 86 seconds.
Is it? You are saying 3 by 86 seconds. This value is equal to 0.1 or less than 0.1?
Sir, it is less than 0.1.
This value is less than 0.1 seconds. Then what is the answer, student?
Sir, then it cannot be heard. Echo cannot be heard.
ठीक है? No. ठीक है? No echo can be heard. Because our time gap should be around 0.1 second. And this value is much less than 0.1 second. Some questions, they will involve some work from us. We have to try and find the answers. All right. We are trying to attempt some questions, trying to learn. The whole game is to learn, students, and find what is happening. Next question is coming on the screen. Why do we hear sound produced by humming bees while the sound vibration of pendulum is not heard? What is the humming bee? Do you see? Listen to humming bee sound.
Yes, sir.
What answer we will give them?
Sir, humming bee sound, its range is between 20 hertz to 20 kilohertz.
Which is audible range.
Yes, sir.
Okay. And vibrations of pendulum.
Sir, it is less than 20 hertz.
That is infrasonic.
Yes, sir.
So it can be heard. And it cannot be heard. Cannot be heard. There is because nowadays descriptive questions are coming. We have to write, but how much we have to write, we have to be careful. We don't have to write too much. There is no need of writing too much because it will not help us. We have to write as less as possible. Another question is, if any explosion takes place at the bottom of the lake, what type of shock waves in water will take place? Explosion at the bottom of the lake. The sound does travel in water. What type of shock waves are there in the water?
Sir, longitudinal waves.
We are aware what type sound travels in what form. Sound waves are longitudinal waves. That is the correct answer. Every time we talk of sound, these waves are longitudinal waves. Sound produced by a thunderstorm is heard 10 seconds after the lightning is hit. Calculate the approximate distance of the thunder cloud. This question we are giving you as a homework, students, because some calculation is required. You can find the time of the light and the observer, then time of the sound and observer, then find the difference of the two sounds. and then we can find. The distance is the same.
Yes, sir.
Sound produced by a thunderstorm is heard 10 seconds after lightning is seen. Distance of the thunder cloud from the observer. And there is a, this is the distance posing. X is the distance. So you have a lightning. And then you have, what is the speed of light?
Yes, sir.
What is the speed of light?
3 into 10 power 8 meter per second.
And what is the speed of sound? Lightning. These speeds are distance. If x is the distance, thunderstorm, thunder cloud, and this is the hearing, where we are hearing, and observer. So you have a light observer and sound observer. What is the formula then? Velocity is equal to distance by time. Then what is t? Time. X by v. X by v. So you can find for light, what will be t for light, student? Time taken for the light. X by, what is the speed of light? And what is the time for the sound? X by 340. If this is in meters, we have meter per second. Sound will be heard later. Then
Yes,
the
sir.
time of sound minus time of light is how much? Gap is how much? 10 seconds. Put the values. X by 3 in 340. Minus x by 3 into 10 power 8 is equal to 10. Clear?
Yes, sir.
This value, but one thing is there, you can make this value is much larger than x by 3 into 10 power 8. Is it?
Yes, sir.
Now you can neglect this. Then what will be left? X by 340 is equal to 10. Then what is the value of x?
3400 meter.
All right. See, that questions can be put in many ways, student. We just have to work them out. And therefore, we have made an attempt to answer the questions which were given in the quiz. And as you can see, you get 14 out of 15. So that's a good attempt, good score. And well done. And this ends up the session right here, and then we will meet you in the next class. We have more topics to be covered. Before that, there will be a lot of question answer sessions also, just like this. Okay, bye-bye. Then we see you next time.
Thank you, sir.